Hello students and friends, most welcome to Dr. Acharya Academy. Today I am going to discuss the gas laws, especially Boyle laws. And this topic has been taken from the Unit 5 of the Chemistry CBSE Class 11 syllabus. Today's class number is 098. Gas laws, especially on this field, Boyle's, Charles, Gay-Lussac's and Avogadro's worked this area, and they formulated some laws which is called the gas laws. Today I'll discuss in this class about the Boyle laws. So Boyle laws is the relation between the pressure and volume of the gas, and on the basis of the experiment, the Boyles reached to the conclusion that at constant temperature, we have to mention always at constant temperature, the pressure of a fixed amount means the number of moles, and which is denoted by the small letter n. So the pressure of a fixed amount of gas varies inversely with its volume, and this is called as Boyle's law. So mathematically we can write in this way, this whole, that means P is proportional to 1 by V. When it is 1 by V, that means inversely proportional with the P, and in bracket it is written there at constant temperature symbolized by capital letter T, and we know the number of moles symbolized by the N. And if we simplify this equation, then it will be P is equal to K1 multiplied by 1 by B. Here we have to remember that volume, when we mention, this is always the capital letter V, and when pressure we mention, there is a small letter P. And here the K1, it is the proportionality constant as per mathematical rules. So in this equation, the constant is the K1, small letter K, subscript 1. So the value of this K1 depends on the amount of the gas, temperature of the gas, and the units in which P and V are expressed. So from the equation, we can get this equation PV is equal to K1. It means that at constant temperature, the product of pressure and volume, that means this PV, of a fixed amount of gas is constant. If a fixed amount of gas at constant temperature, suppose capital T, the volume is V1, capital letter V, subscript 1, at pressure P1, that undergoes the expansion And the second situation, when the volume becomes the V2 and pressure becomes the P2, then according to Boyle's law, P1 V1 is equal to P2 V2. Because from the discussion we understood that PV is constant. So when the P1 V1 is constant and P2 V2 also constant, so in general we can write the P1 V1 is equal to P2 V2. So we can rearrange this equation that P1 by P2 is equal to V2 by P1. Now we'll look about these two graphs. Left side, the figure A, here you can see that what of the x-axis, it is the volume, and what is the y-axis, it is the pressure. And at the temperature 200, one curve is there. It is at the bottom in this case, and with the increase of the temperature, that means in this case the 400 Kelvin, then this curve is above 200, and similarly when the temperature is 600 Kelvin, then the volume and this pressure curve also above 400 Kelvin's curve. So another situation here you can see when the volume, that means inversely proportional 1 by V. Left side you can see that we consider only volume V. Here volume in respect of 1 by V is the x-axis and y-axis pressure. So when the pressure P against the 1 by V is plotted at different temperature T1, T2 and T3. So this type of straight line used to come. So in the left side we are getting the curved nature of lines, but in right side it is a straight line in this. So here it is mentioned that these all are called the isotherm, because at a particular temperature each curve you are getting right side and left side. So when the temperature is constant, in this case also constant, because when 200 Kelvin then one curve you are getting, when 400 Kelvin another curve you are getting, and for the temperature 600 Kelvin other type of curve line we found. And right side also different temperature, this T1, T2 and T3 you are getting different straight line. So when the temperature is constant, then it is called the isotherm curve or isotherm straight line. So higher curves corresponding to the higher temperature, and which temperature is increasing, then this curve also going to higher side. And in both cases, you can see the both cases it is like that. And it should be noted that the volume of the gas doubles if pressure is half. Definitely from this equation, P1 V1 is equal to constant. When V will be double, then pressure should be half, so that these two and these two will cut, and ultimately the PV portion should remain constant. So experiment of Boyle's, which is in quantitative manner, it proves that gases are highly compressible, because when a given mass of a gas is compressed, the same number of molecules occupy a smaller space. And it means that gases become denser at higher pressure. So when we are calling about denser, then we have to count density also. So one more relationship can be obtained between density and pressure of a gas by using the Boyle's law. So here it is a relation. If you consider the density denoted by the small letter d, then dV is equal to m. M means the mass denoted by the small letter m of the gas. So here if we put the value of the V from the Boyle's law equation, we obtain the relationship because we know the m mass and V also we can put from the Boyle's law, then automatic d, the value of the d we can calculate. So in this table, you can find the effect of pressure on the volume in a particular moles of the carbon dioxide gas at a particular temperature. So this table is there. This is for your reference. What is the relation between the pressure and volume in respect of the carbon dioxide gas mentioned here. So now one problem we'll discuss. Whatever the equation we got, on that basis P1 V1 is equal to P2 V2. That means P1 by P2 is equal to V2 by V1. On this basis, this problem is formulated. So we'll solve this. The balloon is filled with hydrogen at room temperature. It will burst if pressure exceeds 0.2 bar. Bar means this is the unit of the pressure. If at 1 bar pressure, the gas occupies 2.27 liter volume, up to what volume can the balloon be expanded? So here pressure we got 0.2 bar, another pressure is 1 bar, and volume is the 2.27 liter. That means if we consider P1 by P2 is equal to V2 by V1, this equation we got the 3 number. So one equation, if we get the 3 number, then fourth number we'll get usually by simple mathematical calculation. So here it is mentioned P1 V1 is equal to P2 V2. So if P1 is equal to 1 bar, this is the 1 bar. And in that case, the V1 is the 2.27 liter. And when the P2 is the 0.2 bar, then the equation is like that, V2. Now it is unknown, we have to calculate it. V2 is equal to P1 V1 by P2. And after calculation, you are getting the V2 is equal to 11.35 liters. So what is the conclusion? Since the balloon burst at 0.2 bar pressure, then the volume of the balloon should be less than this value, 11.35 liters. I hope that you understand this Boyle's law clearly with some example calculation. And what is the isotherm, that also you understand from this class. And thank you so much for watching this class.